You'll notice the objectives for today. By the end of the notes, you should be able to use the periodic table to identify what type of element something is and how many valence electrons it has. You don't yet know what a valence electron is or what I mean by type of element, so you need to be paying attention for what those things are so you can meet this objective. You will also need to be able to describe how electrons are involved in bonding. That's one of the ways we're going to discuss that electrons are important today. And then lastly, you will need to be able to draw an electron dot diagram and then use that diagram to determine if that element is stable and if it's not stable, how many bonds it's able to form. If you cannot do these three things by the time we get to the end of class, you need to visit with me because you missed something. All right. As we learned in the activity that we did prior to these notes, the periodic table is organized in the following ways. By increasing atomic number as you go left to right. So if you remember, atomic number is the number of protons in the nucleus of the atom. And if you look at the periodic table and you go from the left side to the right side across the rows, you will see that the number increases. Okay? The rows that go left to right on the periodic table are called periods. There are 7 of them. 7 rows, 7 periods. When we go up and down on the periodic table, we see that they are organized by having similar chemical properties. So atoms that are in the same column should have similar chemical properties to each other. The up and down columns are called groups. There are 18 groups on the periodic table. Groups 1 and 2, and then 13 through 18 are considered main group. We're going to spend most of our time talking about them. Groups 3 through 12 are non-main group elements. They're called the transition metals, and if you take chemistry with me, we'll discuss them in more detail, but they have more complicated chemistry than main group elements, so we're not going to spend a lot of time on them in this class. The periodic table can give you more information than just similar chemical properties and atomic number. It can also provide you with average atomic mass, which we learned how to calculate in the previous chapter. On our periodic table that's on the wall, it's listed above the symbol. In a lot of other periodic tables, you'll find it listed below. How you can tell that it is atomic mass and not atomic number is that atomic number is always a whole number. Average atomic mass, because it's a weighted average, is going to have a decimal in it. Because protons play a large role in the mass of an atom, in general, you'll notice that atomic mass increases as atomic number increases. But this is not always the case because neutrons also play a role in mass. So every once in a while, you may notice that the mass doesn't increase as you go left to right across the table. The periodic table will also tell you the element type. We're going to discuss, there's 3 different element types. We're going to discuss them. And it will also tell you the number of valence electrons. We're going to discuss what a valence electron is and how to use the periodic table to find that. All right, let's talk types of elements. There are 3 different types. The first type is metals. If something is classified as a metal, you can expect the following properties. They are often shiny. They are good conductors of electricity and thermal energy, aka heat. And they are easily pulled into wires or hammered into thin sheets. So if I hit a metal on something, it is more likely to dent and deform than it is to break. Okay? We call that being malleable or ductile. Excluding hydrogen, the left side of the periodic table is made up of the metals. Hydrogen is on that side for reasons outside the scope of what we're going to talk about in class. But aside from hydrogen, everything on the left side of the periodic table is a metal. The metalloids have properties that are about halfway between metals and nonmetals. So we'll talk in just a moment here about what a non-metal's properties look like. And once you have an idea of what a metal and a non-metal looks like, you can kind of average your way between the two to figure out the properties of metalloids. On the periodic table, these form a small stair-step region that separates the metals and the non-metals. So if you look at my periodic table over here, this light blue stair-step path, that is the metalloids.
Is that it?
There's not very many of them. Okay, they form a little blue stair step on my periodic table. Okay? And the nonmetals are generally poor conductors of electricity and heat. They are most often gases at room temperature, but if they do form a solid, then that solid tends to be brittle, meaning instead of bending and flattening into a sheet or pulling out into a wire, it will instead just break. And these are found on the upper right of the periodic table. So if you look at your little metalloid stair step, then you have the nonmetals above it and the metals below and to the left. My periodic table has more than just 3 colors because I also teach chemistry and I break it down into more groups for the more complex chemistry class. But if you want a simplified version of this, if you open your textbook, inside the back cover, there is a periodic table. So to address the objective for today, if we're using the periodic table to identify what type of element, we really just have to look at location. So if I asked you what type of element is chlorine,
that's a non-metal right there.
Yep, you're going to look at the periodic table, find chlorine, which is Cl. Notice that it's on the upper right of the table above the metalloid stair step, meaning it is a nonmetal. Okay? All right. In nature, it's pretty rare to find an atom or a element just pure and by itself.
Exactly.
It is possible, like if you dig up a diamond or if you find gold, some of those are pure metals. But most elements are going to be bonded with something else when you find them. Okay? A chemical bond is a force that holds 2 or more atoms together. So that right there is your definition of a chemical bond. It's the force that holds atoms together.
Why is it not yellow like a volcano?
When atoms bond chemically, they form a new substance, and when you have 2 or more atoms, we call that substance a compound. Elements form compounds because a compound allows them to be more chemically stable than they would be on their own. So if you find a pure element in nature, you're most likely finding a very stable element because it doesn't need to bond with much of anything in order to be stable. I'll pause there, give folks a chance to write. Recall how an atom is organized. This is going to be necessary for us to explain chemical bonds. Okay? We have the nucleus, which is at the center of the atom, and inside the nucleus we have the positive protons and we have the neutral neutrons. Around the outside, we have the electron cloud, which, as you can tell from the name, is where the electrons exist, and the electrons are negatively charged. Because the electrons are on the outside of the atom, they are going to determine how an atom reacts with other atoms. Okay? They're going to be the things that come in contact with other atoms, right? It's not going to be the nucleuses that run into things. The position of electrons around the nucleus is difficult to describe. We think of them as an electron cloud because it is very difficult to pinpoint where they are. They are in constant motion. They're never sitting still in one location. So just like it would be difficult to describe the location of someone who was continuously running around a football field, it's difficult to describe the motion of electrons because they are always moving. However, each electron does have a certain area of the atom that it is most likely to be found in. Okay? And we call these areas energy levels. Some of these areas are closer to the nucleus than others are. These are called energy levels. Electrons that are closest to the nucleus have the least energy. So if they are close to the nucleus, we say they're in a low energy level, which means they have low energy. The further you get from the nucleus, the higher your energy level is, and obviously the more energy you have. As far as we're concerned, we're going to be talking about two energy levels. The first energy level can hold 2 electrons, and the second energy level can hold 8. Now, it's important to understand that obviously there are atoms on the periodic table that hold way more than 10 electrons, right?
Yeah.
So these first and second energy levels happen over and over, like a stack of the Russian nesting dolls, where you have a smaller doll inside and a bigger doll and a bigger doll. So these energy levels that hold 2 and 8 electrons happen over and over again. So when we talk about energy levels, we're going to talk about the outermost energy levels. So it's very possible that we're talking about the first energy level that only holds 2, but we're talking about the outermost one. So there's going to be other energy levels underneath it. Okay? But for the purposes of this class, you just need to understand there's a lower energy level that holds 2, and then outside that, there's an energy level that can hold 8. Outermost electrons are important for reasons other than just energy. We know that they have the most energy for electrons of that atom, but they have some other importance. Okay? Because electrons are oppositely charged to protons, when you get two atoms near to each other, the electrons of one atom will be attracted to the nucleus of the other atom, just like they're attracted to their own nucleus. This is why we have bonds that form. Those outermost electrons are the furthest from the nucleus, which means that they feel less attraction from their own nucleus and are capable of feeling more attraction from the nucleus of the atom they're bonding with. So only those outermost level of electrons, which we are going to call valence electrons, are the electrons that participate in chemical bonds. The number of valence electrons determines the number and the types of bonds that an atom can form. You can determine the number of valence electrons by looking at the periodic table. For groups 1 and 2, and then groups 13 through 18, the ones digit of the group number is the number of valence electrons. So if you look at the periodic table, if you're in group 1, you have 1 valence electron. If you're in group 15, you have 5 valence electrons. Again, we're looking at the ones place in the number. So the maximum number of valence electrons you can have is 8. Because remember, that second level can only hold 8 electrons. So if we're looking at your valence electrons, the outermost level, the most you can have is 8. Okay? The number of valence electrons for groups 3 through 12 is more complicated to discover, and it's beyond the scope of what we're going to learn in this class. So just know that it's more complicated than the other ones, and we are not going to currently discuss it. Okay? Which means I also am not going to ask you questions about how many valence electrons they have. We're going to stick to the main group elements, groups 1 and 2, and 13 through 18. Electron dot diagrams are something that we use to represent the number of valence electrons that are in an atom. It's a visual representation. Okay? To write an electron dot diagram, you're going to follow the following rules. Step 1, identify the element, get its symbol, and write that symbol down. So you'll look at the periodic table. The symbols are the big bold letters, 1 or 2 letters maximum. Then you're going to identify the number of valence electrons. Remember, you can look at the ones place of the group number to identify this. Then you're going to take dots that represent the number of valence electrons and put them one at a time around the perimeter of the symbol. You're going to start on top or on the right if you prefer, and you're going to go counterclockwise. So if you start on the top, you'll go to the right, bottom, and then the left. My brain's backwards. As long as you're putting them one at a time, the direction you go is not super important. Then you're going to repeat until you've used the correct number of dots. Remember, this matches up with your number of valence electrons. And then to determine if the atom is chemically stable, you look at your dots. If all of the dots on the electron dot diagram are paired, so they have a pair with them, then your atom is stable. If they are not paired, then the number of unpaired dots will tell you how many bonds that atom can form. And specifically, it'll tell you how many bonds that atom needs to form in order to become stable. So let's do an example. If I look at the periodic table and let's say I'm going to take boron. The symbol for boron is B. I look at the periodic table, it's in group 13. So if I look at the ones place of that, I know it has 3 valence electrons. So based on this, I'm going to draw my dots. 1, 2, 3. So 3 dots. I look at this. Is this atom stable? No. It's very unstable because it has no pairs, right? So how many bonds is it going to form?
4.
3. It's going to try and pair up each of its unpaired electrons. So it's going to form a total of 3 bonds. And that will help it be stable. All right, let's try again. This time we're going to do sulfur. What group is sulfur in?
20.
It is in 16, which means it has how many valence electrons?
6.
6. So we're going to go ahead and draw those dots one at a time. 1, 2, 3, 4. And since we've now gone all the way around, we'll go back and pair up for 5 and 6. So, is this atom stable?
Yeah, it is. No, it's not.
No, it's not. How many bonds will it form?
5, 4,
2, because there are 2 unpaired electrons right here and right here. They are not paired up, so we have to form bonds to pair them up and become stable. All right, last one. Let's do xenon. Xe. What group is xenon in? It's in group 18, which means it has how many?
Stable.
How many valence electrons? 8. So we'll go around. 1, 2, 3, 4, 5, 6, 7, and 8. Is this stable?
Yeah.
It is. All of its electrons are paired. So how many bonds will it form?
4.
0. When atoms are stable chemically, they tend not to form bonds. All right. Atoms are stable if they have 8 valence electrons. All atoms that are in the 18th group, which we call the noble gases, are stable on their own, and therefore they don't tend to get involved in chemical reactions. Other atoms have to form bonds in order to become stable. Hydrogen and helium are exceptions to the 8 rule, and here's why. They don't have enough electrons to go into that outer energy level. They only have, hydrogen has 1 electron and helium has 2 electrons total. So they only fill that inner level that, remember, we said only had 2 electrons in it. So because that one can only hold 2 electrons, they are full and stable with 2 valence electrons, which is why helium is over with the noble gases, because it has 2, and why hydrogen tends to form only 1 bond and become stable, because that fills its outer shell. Because remember, they don't have that 8 shell. They only have one that holds 2. Questions? Okay.